Hi, Assalamu alaikum, peace to you. In this video, we will learn how to analyze and design the combined footing in SAFE 2016. First of all, we will go uh, from the zero level. I am going in the file, new model, and here is the design code ACI 31814, and will use the metric system, SI system, but you can use US default whatsoever you like. So I am hitting OK, and now from here I will select the combined footing. So there is also all other types of footings like base mat, a single footing, and here I am clicking combined footing. In the combined footing, here is showing the plan dimensions like left edge distance is 2 meter and right edge distance is 2 meter, means left edge and right edge, and top edge distance and the bottom from top and bottom both are 2 meters, and load spacing and the spacing between two foundations is 8 meters. So whatsoever you like, you can adjust according to your desired loads and desired loading geometry conditions. And here is the loading condition. Here is P, dead and live loads 1500 kilonewton. So I am here also applying a little bit movement like 60 kilonewton meter mx, and also in the load to type in 60 in here. So whatever the movements are you are having, you can put according to your desire to design the combined footing. So I am here putting the footing thickness 600 millimeter, but after in the main window you can change according to your needs. So here I am putting the subgrade modulus basically to model the foundations to match the real conditions. Like in the real conditions, we are having the bearing capacity, allowable bearing capacity, and the allowable settlement. So I am here going to show you how to calculate the soil subgrade modulus. In the soil subgrade modulus is equal to pressure over deformation. Pressure is basically allowable bearing capacity, which we get after from the field testing or from the laboratory testing, and the deformation is the allowable settlement in the foundation. So whichever type of foundation you are designing, so according to that the allowable settlement you can use. For example, in isolated footings you can use 25 millimeter, and for the mat or raft foundation you can use 50 millimeter as a allowable settlement. And now here I am showing the calculation for the subgrade modulus, and allowable bearing pressure is the 200 kPa and allowable settlement is 25 millimeter. The soil subgrade modulus will be K is equal to 200 divided by deformation is 25 divided by 1000 to convert into meter. So here I am getting 8000 kilonewton per meter cube. So I will put in case of in this space of modulus of soil subgrade modulus 8000 kilonewton per meter cube. Okay, so after hitting OK, you can see the footing, and as you have as you want to model in the CSI SAFE 2016 software. So before going further, I will first draw the design strips, add design strips. So here you can do by automatic, or you can also draw by manually. Like here I am drawing the design strips. Here draw design strips. Strip layer is A, and from here to there, and in the other direction I am naming it B, from here to here. Why I am doing this assigning the design strips? Basically the software design the foundations in two ways. One is FEM finite element method, and second is the The strip design method. For the strip design method, we have to assign the strips like I did now in this foundation. And now I am going to save this model with the name combined footing design. After saving the model, we have basically applied the loading successfully and the boundary conditions, like we have defined the soil subgrade modulus. We can also check again, define in soil subgrade modulus, and here is the soil subgrade modulus which we have defined, soil 1. Here is 2, but here which we defined soil is 8000. Okay, now we can check. We have defined the soil property, soil. Okay. Before running the analysis and design, I am going to define the load combinations. There are 2 load combinations already defined, so I will just delete them, and I will assign default design combinations according to service normal conditions. Okay, and you can check the load combinations: 1 dead, 1 live, and 1 dead. So in the design combinations, design preferences, you can see the covers, as for example these are slabs, so prefer bar size whatsoever you want. Okay, in design combinations we will select service, we are designing according to service normal. Okay, so now I am running the analysis and design. So after running the analysis and design, you can see display show deform shape against load combinations. Apply. Here is the maximum is 8 millimeter, which is less than 25 millimeter, so it's okay. Again this again second combination, again the settlement in the foundations at all the points is less than 25 millimeter, which is okay. So now I am checking the bearing pressure, show reactions, soil pressure against apply. Here is at maximum minimum are less than 200 kPa, so it's okay. So for second combination, that's also okay. So now I am going to check the punching shear design check. So the punching shear design checks are less than 1, so that's are okay. So here are basically 3 checks: pressure under footing less than 200, okay; deformation under footing less than 25 millimeter, okay; and punching shear is less than 1 is also okay. Preferable should be less than 0.9. If you are failing in any check, go towards the inputs like geometric. It means you have to change length of the footing, width of the footing, and thickness of the footing, and you can also change the material property like concrete, compressive strength, etc. So here now I am going to towards the design. So all checks are okay. Show slab design. In the show slab design, there are 2 methods of design basis. One is FEM, second is strip based. In the FEM, you can for example, you want to see the top reinforcement, how much is required. So here you can see the top requirement of top reinforcement. So like in the bottom, here under the footing, bottom reinforcement required. In the middle, no. Same way in the second. So I will prefer in the strip based. In the strip based, for example, in the layer A and layer B. Apply. In the X direction, layer A, here is the footing area required 1561 millimeter square per meter. So in the Y direction is the B strips. Here you can see the top and bottom reinforcement requirement in the Y direction. So I will just apply. Here is the required reinforcement in the top and bottom direction of the combined footing. So I will just provide, for example, number 12. Here the rate of 250 millimeter spacing, but this provided reinforcement is still less than the required, so I will just increase, for example, to 20, apply. So still in the reinforcement, what reinforcement? Top I am just decreasing the spacing it to 150, apply. So now it means if we provide this reinforcement, I am just showing the demonstration video, so you can change according to the desired or optimization way. So here you can see, and also there is a one beautiful function of detailing. So in the detailing you can see the drawings. Okay, drawing sheets, cover sheet showing the notes, footing layout plan, footing table. Here it is showing, for example, these are bar A, bar B, and total thickness is 600 millimeter, so that is 0.6 meter. Ly Lx ran by geometry dimensions, and footing, for example, F1, so it's 22 number 14 bars and 18 number 16 bars in the A and in the B directions. So that's all. Have a nice day.